Well, I've been writing this book for 5 years now, and my understanding of it has evolved quite a bit. But the thing that impressed me most recently in thinking about how to explain terrestrial nuclear energy is a speech that Richard Feynman gave in 1959, almost 50 years ago, and it's commonly thought of as the introduction to the information age. He gave a speech that he called "There's Plenty of Room at the Bottom," and what he was talking about is at that point nobody really realized how much information you would be able to store in the atom, in a molecule. The example he used was writing on the head of a pin, and somebody had just said, well, you can now write the Lord's Prayer on the head of a pin, and microfilming had just came in, and he said, that's nothing. He took it down. He said, if we just miniaturize, he was just talking about miniaturizing letters, but he said, if we miniaturize the Encyclopedia Britannica, every letter would be approximately the size of a dot, of a period on the page. But he said, we have electron microscopes now that could read that. You could telescope right down to that level and pick up that, store and retrieve that information. So he was saying there's plenty of room at the bottom to store information. Now, he didn't even get into the computer logic, which is the ones and zeros, if you code things in ones and zeros. And then when you get down to electrons, we know enough about electrons to know that they have different energy stages, that when we combine things chemically, we're moving electrons between molecules, and that if you code those positions, those different energy levels, you can write information, you can store information in code, because all you need is two different positions, a 1 and a 0. So Feynman really predicted the entire information revolution at that moment. There's plenty of room at the bottom. We can just keep going down, down, down. Now, he imagined storing the entire Encyclopedia Britannica on the head of a pin. Now, we're at the stage now, I think last year they're measuring it in exabytes. We stored enough information last year on the internet to take up 12 stacks of books that would stretch from here to the sun. And we're still improving. We had 5 years after Feynman talked, Gordon Moore of Intel made this proposition that energy storage seemed to be doubling every 2 years. The number of transistors you could put on a chip was doubling, and therefore information storage itself was doubling. And Moore's law has held now for 40 years. We're still doubling it. Actually, the time has shrunk a little bit even. And we're still going in that direction. So as far as information, there doesn't seem to be any limit. We could get right down to the quantum level of a single electron. You could store a bit on a single electron, and you could probably put all of human knowledge on the head of a pin at that point. So we've accomplished all that. But now these people in Silicon Valley are saying, wow, we've got an energy crisis here. You know, we did a great job of pulling off that information revolution. We're going to tackle energy next. Let's tackle energy. So a lot of Silicon Valley entrepreneurs now have gotten into energy companies, and they say, well, we're going to take solar energy and wind energy and all these alternate renewable energies, and we're going to do the same thing that we did for information. And several people have said specifically, if we could find a Moore's law for information, we would have, for energy, we would have all the energy we needed out of the head of a pin or something. Not that much yet. So that's the principle, and a lot of Silicon Valley money now is being put into alternate renewable energy strategies. Now, the difficulty is this. It's not going to happen. It's not going to happen. And the reason is very simple. Energy is not information. They are not the same thing. They are not equivalent in any way. And what it was done for information is not going to be done for energy. And we can say that without without any doubt, without any hesitation. You're not going to have an energy revolution based on. As we go down, down, down into the atom, you're using less and less energy at each level to store the same amount of information. So what we've done is we take information equals energy, we use less and less energy. That's the secret of Moore's law. But the point is, if we go down into the atom looking for energy, what we find is less and less energy. There is simply less and less energy the further down you go in the electron shells. Let's keep that distinction and keep it in mind for a couple of minutes here, because there's more to be said on that. But as far as electrons are concerned, now when we talk about electrons, we're basically talking about chemistry. Chemistry is the exchange of electrons between different elements and different molecules. So when two atoms get together and form a molecule, a compound, they are a compound, not a molecule. They are exchanging electrons, and they're changing electron energy levels. So what we have, this is where we get most of our energy now. Most of our energy comes from the fossil fuels, oil, gas, and coal. And the energy stored in those substances is in fact stored in their electrons. They're chemical compounds that have been formed with solar energy. They were formed by plants using photosynthesis. And what you get is stored energy stored in the structure of the electrons. Now those, we know the magnitude of that energy. The simplest bond, which is a hydrogen bond, which is a carbon molecule, and a hydrogen molecule, this is what all coal, oil is made of. It's 1 electron volt. You get 1 electron volt with every hydrogen bond. Now, that's the bond that we're breaking when we release the stored energy and when we burn things. When we burn coal, we burn oil, we're breaking hydrogen bonds. There's only so much, there's 1 electron volt in each bond. The only way you expand on that, you can't go down, down, down. As far as electrons are concerned, the only way you can expand on that is to find more hydrogen bonds, which means find more coal, find more